Yeah, that's why we want to replace it, right? Platinum, if they keep it in this, very thing, and platinum doesn't corrode very fast, but it does, right? So it's like, right. Okay. And then force is in newtons. Okay. So for example, if I've got 2 kilograms and I accelerate it at 5 meters per second squared, right? I get 10 kilogram meters per second squared. Okay. That is also 10 newtons. There we have it, right? Okay. So a newton it's our first unit that is made up of other units, right? So 1 newton is 1 kilogram meter per second squared. Yeah? And it's as simple as that. And we're going to do some whiteboards of that, but first I got to do one more stupid demonstration, right? The third law is, I think we all knew this. How many people knew all the 3 laws before you came in here? That's good. But I'm going to claim that I taught them to you. Okay? The third law is that there's no way for one single force to exist in the universe. Okay? There's always a reaction force. So if I throw the ball, okay, the ball throws me. If I throw this into the hall, someday a kid's going to walk by. Okay? There was a kid out there. I missed them. Okay? All right, so I'll zoom in on the board here a little bit. Okay? So this, when I throw the ball, I exert a force on the ball, but the ball actually exerts a force back on me. If I were to ride on that air track, they keep not buying me, right? But if I had a bag of softballs and I'm riding on that air track, are you picturing this? And I just keep going, thoom, thoom, thoom. I'm going to go backwards this way. It is a way that I could propel myself, yes? If I had a leaf blower and I pushed air that way, the air would push me this way. If I had a rifle and I went boom, or a shotgun, even better, right? With slugs in it, okay? And I go boom, the shotgun would exert a force on the slug and send it that way, and it would exert a force on me and send me backwards, yeah? And it's a lot, okay? If you've never fired a big rifle or a shotgun, I'll give you a clue. Hold it against your shoulder before you pull the trigger. Don't hold it away from your shoulder, because if you hold it away from your shoulder, the stock hits your shoulder with sufficient force as to break it. You can break a collarbone or a shoulder because it just goes smack into your shoulder. Whereas if you lean into the thing, it'll, right? And then the other thing is, you got to watch your footing, right? Because when you kind of want to anticipate it. The big shotguns have a lot of kick. Okay. Now, I have a demonstration for you. Regardes. Okay, now, I know, this thing is just crazy. I told Duggan, I said, look, you need to go out and get, that cart that we use to demonstrate boat crossing river. Do you see how dead that thing was? I mean, it's like on its last legs. We've had it it's a cheap toy that was supposed to last 1 season. We've had it for 20 years, right? Okay, so Duggan goes out and he buys this. This is like hopelessly complex. Let me just show you some of the things it does, right? It's got a horn. That's kind of cool, isn't it? And by the way, there's no stopping it. Once you get the horn going, it's got to do its whole shtick, right? Okay? It's got a motor. You got to start the motor before you make it go, right? I don't know, I got to make sure the microphone's picking up that throaty roar, right? It's got a security system. It's nice. Isn't that nice? It doesn't actually work. It's like some giant could steal your car and I don't know. Maybe you got to open a door. They don't open. Okay. Anyway, what pushes a car down the road? Its engine does. Yes, that's where the energy comes to push it down the road. But what physically is the thing pushing the car down the road? The wheels rotate. Yes. Yes. Here. Oh, here. Here. The wheels are rotating. Is it moving? No. What physically makes the car go down the road? The road? What? It's pushing on the road, yes? Yeah, there we go, right? Okay. And so it pushes on the road and the road pushes back on it. It pushing on the road, by the way, pushes the road that way. Excuse me, there's nothing more exciting than this. Okay? It pushing on the road would tend to push the road that way. The road is generally attached to the earth, yes? okay, and does not move, okay? So let's just do a little experiment here. Okay, I've got a new road here. Here's my new road. There we have it. Okay, it has wheels, it is touching the road. Are we ready for this? You gotta watch, it's only gonna happen once. Are we ready? Go forward. What happened? Well, that time the road moved, didn't it? Yeah, there we go. So normally, gentlemen, can I interrupt? Normally we push on the road and the road doesn't just fly backwards, yeah? Okay? Normally it's made of very heavy stuff like the earth, you know, or something like that, right? Okay, and so when we push the road backwards, it stays put largely, right? And the road pushes us forward. So that's a crazy thing, right? The road pushes the car down the road. It's the reaction force, right? Car pushes on road, road pushes on car. That's a weird thing, okay? All right, a little applause for that guy. All right. F equals ma. And then the only final thing I would add to that you need to add is that this acceleration can come from all the places that acceleration has historically come from. So A is change in V over T, right? VF is VI plus AT. Any formula with A in it now is, of course, fair game. We can have you solve a little X linear kinematics problem, right? Change in X is VI T plus 1/2 AT squared, right? All of these A's are A's that we can put in there. VF squared equals VI squared plus 2AX. Okay? So all of these guys, we could solve for that acceleration, that one, right? And we could plug them all into there. Yeah? And accelerations can be positive and negative, and forces can be positive and negative. Mass is always positive. Shall we try some of these?
So,
Yeah.
the road doesn't give at all.
Yeah.
Basically, all the force that is propelling back at the road is the amount of force pushing back is the same that
Exactly the same, but they're acting on different objects.
it's not giving at all.
Yeah.
So if the road was to move 10 meters per second that way, and the force, that total force is like 3, then wouldn't they just be moving 20 meters that way?
No, well, okay. The question is about the road, because the microphone's not picking you up, right? The question is about the road and the road moving and the car. And definitely in this case, the car does all the moving because the Earth is so big, right? If they had equal masses, then yeah, when the car was going 30 miles an hour this way, the road would be going 30 miles an hour that way, right? That's sort of the answer, I guess. Okay, I'm gonna. What? Yeah, I do have erasers here. So we're going to do the whiteboards on the Newton's second law thing, and you can do them along with us at home. I'm going to stop recording.